16 upon 3 into A into B. This is the answer here. Okay, so 16 upon 3 A into B is square unit is the answer. Question number 4th we have done. Okay, now let us talk about the next question, which is the question number 5 or 5th question. Let me now talk about question number 5th. What does it say? And what kind of question is 5th one? Let me check it. Okay, so these two questions, question number 3 and question number 4, they were of similar nature, but only difference was A and B, constant values. Okay, now let me talk about question number 5th. What does it say? Find the area common to the ellipses a square x square plus b square y square equal to 1 and b square x square, okay, a square y square equal to 1, where 0 is less than a is less than b, so b is greater than a. Now let me find out what are the some tracing points. This is looks like a lengthy question, no problem. Question number 5th here. The two curves, let me change the marker. Okay, so question number 5th, it says the first a square x square plus b square y square is equal to, this is the first parable, first ellipse, okay. Then b square x square plus a square y square is equal to 1. This is the second ellipse. Second ellipse is this b square x square plus a square y square is equal to second one. So this is the second one. Alright, here 0 is less than a is less than b, means b is greater than a or b is greater than a. It is given to us, no problem. Now let us find out the common points. First of all, what are the common coordinates of them, intersecting coordinates. First let me draw these two ellipses. So we know that these, what are the tracing, let me talk about some tracing probability. First point, first curve is symmetric about both the axes because x and y both are even power. And second is also symmetric about both the axes, x and y, but here x and y both are symmetric, both are sorry even power. Both, I mean equations, both curves are symmetric about both the axes. Simple point. So here both the curves are symmetric about both the axes, x and y. Why? Because x and y both are even power, and x and y both are even power. Alright, second point, both are not passing through the origin because there is one independent constant term which is independent without any variable. So both are not passing through the origin. Both the curves will not pass through the origin, will not pass through the origin. Simple logic of tracing origin, as both have a constant independent term. Both have a constant independent term. Okay, so now let me talk about so how to draw them. Let me first frame their rough figures. Then what are these ellipses are to be drawn? Let me find out the common point of such kind. This is x-axis, x dash, y-axis, and y dash axis. Okay, so let me draw. This is the curve here. first ellipse. Second ellipse, if I draw, let me take the second ellipse here. Now this is a curvilinear type of figure. It means we have to draw a perpendicular from this point. Okay, so this point will meet here. If I take this origin 0, 0, and this is, let me take again n, this is a point here, common point. What is the common area? This is shaded portion, which is the common area, and this portion also. Now we have to just think about, what is the common area? This area plus this area. If I take this as the B point, this is O, this is N, this is, let me take A, this here it is A dash point, let me take this is A point. Okay, so what is the, okay, the common point we will find out. This A is the common point of both the ellipses that we will calculate, and these two ellipses, I mean the second ellipse cuts the x-axis at what point? We will just talk about it. This is the second ellipse here, which is intersecting the x-axis where y is 0. We will calculate from the second ellipse what is the value of x here. Okay, so we will take the limits from, and this is common point A dash. Here x coordinate will be at n point. What is the x coordinate at n point? The limits will be from 0, 0 to 0, 2. This is 0, 0 origin. And what are the coordinates of n? The A dash will have the same x coordinate as n is having. A will have some different x coordinate. The limits will be of this common area. If I take the common area, then the common area is OB A dash A. O. Okay, this is total common area. But this area comprises OB A dash N plus N A dash N, or A dash A N. This is the second area which is common. So we have to add these two common areas. Okay, so that is the point here, that OB A dash N area, which is in the second ellipse, plus the first ellipse, or sorry, this is in the first ellipse. First area is in the first ellipse because this is the first ellipse portion up to this point. Let me darken this. Then the second ellipse is this one, which also let me darken. Under this ellipse, second ellipse, this area is under second ellipse. So equation of second ellipse, we will substitute value of y from second ellipse from first ellipse. So these two are added up. But this kind of area will be 4 times. While this area plus this and this, there are 4 sections. So 4 shaded portions are to be added up. If we find out the area of this one common area and make it 4 times, then the total area of common two ellipses will be obtained. Okay, that is the main objective here. We will calculate that point here. So let me solve it one by one. And if I take here, let me take, this is A dash, let me take this is B dash here. Okay, or AB, if I take this as C point, let me take C point here, this is C dash point, no problem. This is A, and if I take A dash not here, then let me take A dash here, and this is, let me take P point. Okay, so coordinates of P point we have to find out, which are common to both. So let me take the intersecting points of both the curves, and then we will find out what is the value of y for the two ellipses. Okay, so common area, solution, we have to find out this. So first point, that both the, let me write here, both the curves are symmetric about x and y both axes. Sorry, about both the axes. about both the axes x and y. We have seen here the second curve and the first curve, both are symmetric to x-axis. This is x-axis and y-axis. They have the similar shape on both the sides of y-axis as well as on x-axis. So this is how symmetric about both the curves are symmetric about both the axis or x-axis and y-axis. Second point, they are not passing through the origin. No curve is passing through the origin. Here no curve will pass through the origin. Will pass or is not passing through the origin. Will pass through the origin. This I have already described. Okay, so just not to be repeated again and again. Now let me talk about then what are the common intersecting points. So we have to find out coordinates of n, coordinates of a, only coordinates of p we will find out undoubtedly. So what are the intersecting points here? If I find a, that is simple point, but n or p or n, whatever the x coordinate of n is there, so p will have the same x coordinate. Let me find out the intersecting point. Solving these two equations. For intersecting point, points, p, etc. P, this point, all these points will be intersecting points. So for intersecting points, solving both the equations first and second. What do we get? Okay, so because we have to find out value of x coordinate first find out. So value y we have to remove. So if I multiply this by a square first equation and second by b square, okay, so it will be a square b square, this will be a square b square, same. Then y can be intersecting. So multiplying first by a square and second by b square, so we get first by a square, it will be a4 into x square plus a square b square y square is equal to a square. This is the third equation, multiplying first by a square and then second by b square, it is b4 x square plus this is a square b square y square is equal to b square. This is the fourth equation. Now subtracting fourth from third, we get this is a4 minus b4 into x square. These two are cancelled out. Y square is cancelled out. I mean, this is equal to a square minus b square. So this implies that x square is equal to a square minus b square divided by a4 minus b4. The denominator can be written as a square minus b square in one bracket, in another bracket a square plus b square. One a square minus b square cancel out, so this is nothing but 1 upon a square plus b square. Therefore x is equal to 1 upon under root a square plus b. This is plus minus because negative values of x will be here at this point, Okay, so these four points are intersecting point P. Let me take here P dash. This is P double dash. This is P triple dash. So all the P's are the intersecting points of both the curves. So x here plus minus 1 upon under root a square plus b square, or square root a square plus b square. This is 1 upon under root a square plus b square x coordinate here. If I substitute the value of x in the first equation or second, so doesn't matter. In the first one, if I substitute, then y can be calculated here from this equation. This is a square upon a square plus b square. The x square is 1 upon a square plus b square. X square is equal to b, then y square can be calculated. Let me solve for y here. So what is the y? Okay, so putting this value of substituting value of x in first, we get this is a square into 1 upon a square plus b square. Why? Because x square is equal to plus b square by square is equal to 1, or b square by square is equal to 1 minus this is a square upon a square plus b square. LCM is a square plus b square. Here it will be a square plus b square minus a square. A square cancel out. So this is nothing but b square upon a square plus b square. So y square is also equal to b square upon b square divided by into a square plus b square. So b square cancelled out. It is 1 upon the same value a square plus b square. So y is also plus minus 1 upon under root a square plus b square. Okay, negative value is for by here. This point is negative by the negative by. Okay, so plus minus 1 upon under root a square. Only this point is required because we will make it as 4 times total area. Common area will be calculated, shaded area. This is 4 times because this and this and this. In all the 4 quadrants, we will have the common area, common shaded area. So if I find out this common area and make it 4 times, or multiply this by 4, we will get a total area, common area. This is n point here, 1 upon under root a square plus b square. This is x coordinate of n. We require x coordinate here, because from 0 to n, then n to a. What is the a here? Let me calculate that. So if I find out from second equation, because this is second parabola, the second point a is lying on the second ellipse. On the second ellipse, a is there. If I substitute y 0, because on x-axis y is 0 from the second one. So putting y equal to 0 in second ellipse, because a value, coordinate of a can be calculated then. So this is b square x square plus 0 is equal to 1, or x square equal to 1 upon b square, or x equal to plus minus 1 upon b. Here it is 1 upon b positive, or this is x square equal to 1 upon b square, or x equal to 1 upon b. 1 upon b and 0, and this is minus 1 upon b and 0. A dash is, and a is 1 upon b and 0. So this is one limit. X coordinate is 1 upon b for a. Now common area, let me find out. So both the limits, for limits x limits x n will be the same, 1 upon under root a square plus b square, and this a will be 1 upon b x coordinate. So limits are calculated now. Now let us do what are the values of y from both the ellipses, equations of ellipse. For first value of y, let me calculate. For common area, y dx is required. For that, y is to be calculated from first one. So it will be b square by square is equal to 1 minus a square x square, or y square is equal to 1 minus a square x square upon 1 upon b square, or y is equal to 1 upon b under root 1 minus a square x square. This is for first ellipse, first curve. For first value of y is equal to this. This is for first curve. That means this is the first curve here. So up to BP, which is the arc of the first curve, which we have to take. For that, y will be taken as this one. For second curve, let me take for second curve. For second curve, value of y from second equation So y square a square is equal to 1 minus b square x square. So y square is equal to 1 upon a square into 1 minus b square y square, sorry, b square x square, b square x square. Therefore y is equal to 1 upon a under root 1 minus b square x square. This is value of y for second curve. Try to understand. These are the two values of y. Now let me find the common area. Therefore the area, total area, therefore the total common area, total common area is equal to 4 times 4 multiplied to the area this. Area OBPAO. OBPAO. This is the common area here. Try to understand. OBPA up to O, the total area, which includes these two shaded portions. Now let me write them here. These are the two values. Let me take this as y2, this is y1. That will be clear. Now let me rub other things. This is the first curve. Y1 is, or f1x. Let me take this as f1x. And this is f2x. Second curve. Y is this value. This is for first curve. Okay, so common area we are finding out. Now let me write here. So this is 4 times into area OBPH divided into two parts. What is that area? Area OBPN, this area, plus area, what is the area? PAN, this area. There are two common areas. Now let me substitute them. So area OBPN is under the curve, this BP curve. BP is the arc of the first curve. Okay, so this is limits 0 to a limit is this 1 upon under root a square plus b square. First curve, first limit is x coordinate. And here this is y1 because this is the first arc of the first curve BP. This is the value of x. This is 1 upon b under root 1 minus a square x square into dx. Minus sign, sorry, plus sign. This is plus sign because we have to add these two areas. There is a plus sign here in between. Area PAN. That means this is limits. Now this is n. Lower limit is same as this first upper limit. This is 1 upon a square plus b square up to 1 upon b. This is 1 upon b into y2. Y2 is 1 upon a under root. This is 1 minus b square x square into dx. Try to understand. This is the total common area. 4 times total common area. Now let me solve this whole. Okay, so we have to solve this equation, this total equation. Limits are known to us. This is limit n to a, and limit x coordinate at n is 1 upon under root a square plus b square, same as p coordinate. And then upper limit for this a is having x coordinate as 1 upon b. So limit 0 to 1 upon under root a square plus b square, then 1 upon under root a square plus b square to 1 upon b. Okay, now let us solve this. So let me rub this whole so that we can have the space to solve it. So total area we are finding out. This is a very good question. Now let me solve it. This is 4 times first limit 0 to 1 upon under root a square plus b square. I'm just writing here 1 upon b, which is constant, under root 1 upon a square x square into dx plus sign this is limit 1 upon under root a square plus b square 1 upon b 1 upon a under root is 1 minus b square x square into dx. Okay, this I have written down here. Let me now solve it. So this will give us the total common area. So now let me solve it. First, further let me take common. Now from this, if I take a square common from the first equation, multiple of x square is a square. If I take a square common, it will come out as 1 upon ab. Okay, so this is limit 0 to 1 upon under root sine of integration a square plus b square. If I take a square common, 1 upon a square in first, and this will come out as 1 upon a. This is 1 upon ab. Under the square root, this is 1 upon a square minus x square now left over into dx plus sine. Again, this is b square. If I take common under the square root, it will come out as 1 upon b. So it will be 1 upon ab. Let me take outside. Sine of integration 1 upon under root a square plus b square 1 upon b, and under the square root 1 upon b square minus x square into dx. Okay, now these are to be integrated. What is the integration of? We know that since integration of under root a square minus x square into dx, this we know about, is equal to 1 upon 2 into x under root a square minus x square plus 1 upon 2 a square, okay, into sine inverse x upon a. This is the integration of this under root a square minus x. This we know about. This same formula we have to apply in both these two integrals. Okay, so this integration under root of a square minus x square dx is given by 1.2 x, the first variable x here, under root a square minus x square as it is, same value comes out to be, plus 1 upon 2 a square sine inverse x upon a. So this formula we have to apply in both these questions. Okay, so this is the formula here. Now let me apply the formula. 1 upon ab. From both I have taken outside. Let me take. So this is 4 upon ab. Let me take outside. Well, 1 upon ab in both the integrals is common. Okay, so integration of first. We'll apply the limits later. Let me first put the integration. This is 1 upon 2x. First one. 1 upon 2 into x upon 2. First 1 upon 2 into x under root 1 upon a square minus x square as it is, plus sine. Now 1 upon a square. So this is 1 upon 2a square. Because here in place of constant a, we have 1 upon a. This is 1 upon 2a square. Same value 1 upon 2a square. Now sine inverse, it will be x upon 1 upon a, that means ax. It is nothing but 1 upon ax. Okay, so this is limit 0 to under root 1 upon a square plus b square. This one. Or let me take 1 upon under root a square plus b square. Limit. It will apply. Plus the second integration. 1 upon ab I have taken outside. So this is also of the same type. 1.2 into x under root. This is 1 upon b square minus x square. Okay, but in this case limit will be some different limit. First limits are 0 to this. Second limits are different. So let me take that separately. This is 1 upon 2 b square. 1.2 b square sine inverse bx only, because x upon 1 upon b, that means b into x. Now limits are here 1 upon under root a square plus b square 2 1 upon b. Okay, now let us solve it further. So let me rub this code. So this common area, let me find out here. What are these two values to be calculated? This is the total area. So first is 4 upon AB, which I took common out of the whole bracket. The limit is here 1 upon under root a square plus b square. So in place of x, upper limit if I put in the first, so it is 1 upon, okay, 1 upon under root a square plus b square. So the first value is there. Oh, okay, and this will be 1 upon a square plus b square. Okay, so this first one is x. In place of x, we will substitute this. So 1 upon 2 under root a square plus x square will come out, and in the bracket under the square root we will have, in place of x as 1 upon under root a square or 1 upon a square plus x square. It will come out as a square. LCM will be a square into a square plus b square. Okay, so that will be, okay, that can be calculated again. So in place of x, let me solve them. So first value is, if I put the upper limit, at lower limit 0 and 0, this whole will be 0 because x into 0, sin inverse x is 0. So at lower limit both are zeros. For sin inverse ax is 0 because sin 0 is 0. For this is 0. At lower limit 0 into this is 0. Only upper limit is giving us some value. Well, at upper limit it will be 1 upon, because x is here. So 1 upon 2 under root a square b square. This is 1.2x, and under the square root, what comes out to be? This is 1 upon a square minus 1 upon a square b square, because x square is there. 1 upon x square plus 1 upon 2. This is a square sin inverse a, because ax is there, which is a upon under root a square plus b square. This is the second value. So at the upper limit only, these two values are these. At lower limit 0, both terms are zeros because sin inverse 0 is 0, and this is x into something. So x 0, if I substitute, the whole value will be 0. So lower limit will make it 0. And the second